Hello everyone, my name is Val from Core Conservation, and this presentation is about handling dampness problems in old buildings and common renovation mistakes. Let's get started. We are going to cover today the top 5 renovation mistakes, then go back to the basics and find out what the Romans have done to solve dampness problems using traditional materials. Then we are going to see some examples and the right way of doing and solving problems related to rising damp, penetrating damp or wind-driven rain, old chimney breast, and waterproofing cellars and basements. These are all quite heavy-duty, difficult applications if you want to do it in a building-friendly way. If you look at the sources of moisture in a building, we can see the picture of a house here. We can see two causes. One, it can be the mechanical causes, which can be like water ingress from roof or chimneys, penetration damp above the ground like rainwater penetration, very common, penetrating damp underground, for example, cellars, splash water, and various building defects like leaks. These can be quite easily sorted by finding the source and plug it in or stopping the flow of water. On the right hand side, we have other causes. We call them electrochemical causes, which occur over long periods of time and they are not always obvious. These include rising damp, the hygroscopic effect of salts or hygroscopic moisture, and condensation. Let's see the top 5 most common renovation mistakes. Before we go into specifics, let's see what is the difference between older and newer buildings. By older buildings, we mean buildings before 1940. Newer buildings, buildings built after 1940 or the Second World War. There are fundamental differences between older and newer buildings. Older buildings are built breathable, the main building material being lime. Newer buildings, on the other hand, are built waterproof, the building material being cement. Mixing modern and older building materials is detrimental to all buildings because it can damage them severely. Mistake number 1, skimming. In order to save money, the old plaster is often left on the walls and it is only being skimmed. For example, we have an old lime plaster, looks okay. So in order to save money, the builder decides just to use a skim. This is often a pink gypsum skim. The problem is that the underlying salts in the old plaster, we can see them, some of them here, kind of this whitish powder. The underlying salts, when the gypsum plaster is applied, start migrating into the skim and will ruin it in a matter of months, resulting in costly repairs later. Our recommendation and good industry practice, always remove the old salty plaster and replaster the wall from scratch. Here we can see the salts coming through after about 6 months. And here as well we can see these white patches. Mistake number 2, dot and dabbing. Dot and dabbing is a budget plasterboard mounting technique which is often applied to save time and money, mainly for the builder. The plasterboard is glued onto the surface of the walls. They use these big dabs of glue, as we can see here, and then the plasterboard is pressed against the wall. The problem with this are twofold. First of all, condensation and mold. The glue acts as a barrier, as a conductive barrier. The cold from outside migrates through the glue and it can create condensation and mold. Also, it can create damp patches because from the underlying salty old substrate, the salts can migrate through into the plasterboard and absorbing humidity from the air, it can result in damp patches on the walls. The right way to do plasterboarding is to always mount the plasterboard on battens. You can use timber battens as shown here, or even better, you can use galvanized steel battens mounted on a frame. with insulation tucked underneath, or even better, with insulated plasterboard preserving the air gap between the wall and the framework. And then once the plasterboard has been mounted, it can be skimmed and painted. This is the best way. Our advice is avoid dot and dab plasterboarding everywhere on the ground floor for an older building, and on external walls, even on the upper floor, and use dot and dab. Use galvanized steel or wooden battens. Mistake number 3, no salt-resistant base coat. It's quite well known in the conservation business industry or all buildings that lime is the prime material. We need to use lime, and lime is the right way to do it as opposed to cement. However, contrary to common belief, lime plaster alone does not guarantee a long-lasting finish. And the problem here, the missing ingredient, as we are going to see it later, is the salt-resistant lime base coat. Regular lime does not cope very well in the presence of excess water and salts. So you can see here you start getting the salts through, which ruins the plaster. And if you apply a salt-resistant base coat, which we are going to see later, this Rinzafo MGN product, a Roman plaster, then the problem can be sorted and the lime plaster is going to last much, much longer. Mistake number 4, using cement instead of lime. Many old buildings are being incorrectly renovated with cement based on the misconception that waterproof cement protects the walls from dampness. And we can see here an old church with red sandstone, has cement pointing, and we can see the salts as the water evaporates start coming through or just near the pointing. Or we can see the building material decay here around the pointing, or here this particular wall has been tanked with a cement layer and the moisture is rising and is damaging the walls above. For this particular wall we have used a deep penetrating damp meter, and you can see the orange area which shows how wet the wall is underneath, while here is a dryer and the moisture basically just affecting these areas where you can see the damage. Cement plasters don't solve dampness problems, they only make them worse. They trap moisture, which later resurfaces somewhere else. What we have here, for example, at this church, the cement blocks the evaporation of moisture, so moisture starts evaporating following the path of least resistance through the sandstone, drawing the salts outside, and the crystallizing salts start breaking down the lime plaster, start breaking down the soft sandstone, and from here we are going to get a similar situation. So this is a bit later, and we can see how the material has decayed. Here we have more decay. A few words about lime and cement. Buildings built before 1900s, 1900, were built on lime, with very few exceptions. Benefits of lime plasters: they are soft, softer than cement, they are breathable, lime allows water to evaporate, keeping the surfaces dry. Warm, lime has large air-filled pores, so it acts as a good thermal insulator. Cement being dense leads to dampness and condensation problems. Lime is antibacterial naturally, having a high pH value, and it's a natural mold killer. And lime is also eco-friendly, it can be recycled. Our recommendations, and everyone else's, use breathable building materials wherever possible. And here are some examples of using cement, which, as we showed previously, it erodes the building fabric, and we can see how much the building fabric has been eroded. This wall was completely covered in cement, and as you can see, it's completely gone, and a large chunk of the bricks are missing. And finally, mistake number 5, sealing the moisture into the building fabric. Cement, plasters and renders, plastic membranes, synthetic emulsion paints, etc. seal the moisture into the building fabric, being non-breathable. This often leads to future dampness problems, such as resulting in cold walls, condensation, dampness on internal walls, flaking, paint, rotten joints, and so on. Solution and recommendation: use breathable materials, and the solution, think in terms of breathable materials rather than moisture blocking materials. How we deal with dampness and getting things right. Let's start with a brief history of plaster going back into the antiquity to the Phoenicians and Romans. Plastering technology is an integral part of handling dampness problems in different situations. The Romans, 2000 years ago, have built buildings, bridges, baths, and so on that still stand and function today. The first type of plaster in history, they were the lime putty plasters, or also known as area lime or putty lime plasters. They have a rich history going back easily 5,000 years, and they are a mix of lime putty, sand, and water. These type of plasters slowly harden in contact with air. They carbonate. They are manufactured or burnt at low temperature, around 850 to 900 degrees, and they have a long life. They last a long time in relatively dry areas. However, they perform poorly and they break down in the presence of excess water and salts. For these type of problems, when lime or the building material has to withstand salts and excessive water, the Romans figured out, they created another type of plaster, traditional plaster, called pozzolanic lime plasters. And by adding to the lime putty volcanic soils known as pozzolans from the town Pozzoli in Italy, where the name originates from, and or crushed bricks, also known in Italian as cociopesto, they adding this to lime, they realized that it creates water-resistant or waterproof bonds, yet keeping the lime breathable. It's just a chemical reaction between these type of volcanic soils and crushed bricks, and the lime putty creates water-resistant bonds. These type of plasters can harden in contact with water, even underground, and they have been traditionally used by the Romans in antiquity in high humidity and marine environments. The famous Roman concrete, which we all heard of probably, which lasted 2000 years, are made of 4 ingredients: lime putty, river sand, red pozzolana, this type of volcanic sands, and cociopesto, the crushed bricks, and it lasted 2000 years. Though it's called Roman concrete, has nothing to do with modern concrete. It was all lime based. So the point is, from lime you can create special mixes which can do virtually or almost everything which cement does. And anyway, from the perspective of old buildings, you can replace cement completely with lime with demanding applications, for demanding applications using the right type of lime. Going further in history, because the natural pozzolans, the original natural pozzolans from Italy, were expensive or not available throughout Europe, they were replaced with other type of materials such as clay and other impurities, up to about 20% of the volume. And that's how the natural hydraulic lime or NHL plasters have been born. NHL, or the hydraulic aspect, means that these also can harden in the presence of water. These first appeared in the 16th century. However, the commercial production started around 1750. The higher firing temperature of these plasters, up to about 1200 degrees, and the mix offered good water resistance depending on strength, but also these plasters were less breathable. On these pictures we can see some bags, NHL 5, 3.5, and this is NHL 2. This indicates the strength of the plaster, how much strength they can withstand, and generally speaking, the harder the plaster, the NHL 5, the less breathable. And finally, modern day today, we are talking about the cements. From the late 1800s, industrialization and increased mass production led to a shift in building philosophy away from traditional long-lasting quality materials in the direction of low-cost, mass-produced, often inferior quality materials that can be applied fast and set quickly. Cements have a practically absent pore structure. They are non-breathable. They trap humidity, resulting in the degradation of the wall fabric. They are very, very strong. The mechanical strength is about 5 to 8 times stronger than lime mortars. So temperature and humidity variations generate high tensile stresses, just stresses inside the material, resulting in the cracking and debonding of the cement from the surfaces. And in these cases, the softer building material, the soft bricks, always suffer because it ruptures much easier. As a result, they are not compatible with all buildings and the use is not recommended. It doesn't mean cement is a bad material. No, it's not. It is just a different material. It has its applications, and in certain areas, they are first class, but in old historic buildings, they are just too strong. They block moisture, and as a result, they are not suitable. Now, let's see the solution. Old Roman pozzolanic plaster. Whatever was 2000 years ago, we have today a plaster mix called Rinzafo MGN, a pozzolanic lime plaster, which is based on an old Roman formula, reconstructed and in use since 1980. There was a whole research program behind it. They find the formula, and then we have it today in a premix format. So what we have here today, we have a Roman waterproofing lime plaster or mortar, which is a special lime mix created specially to withstand very damp and salty environments where other lime mixes fail. It doesn't have any cement, it doesn't have synthetic chemicals, it's all made of natural materials, and the resulting mix is waterproof, salt resistant, yet breathable. Its pore structure, how is this possible? Its pore structure allows for the passage of water vapors, but blocks the larger liquid water molecules. It's clever engineering. These type of plasters have been traditionally and through the history heavily used for conservation jobs in Venice and throughout Italy. It is used as a base coat applied onto the masonry, and it protects subsequent plaster coats from deterioration, so it acts as a salt blocking layer. It has a very long life expectancy, at least 40 years, even when submerged in seawater. And using these plasters increases the life expectancy of the plastering by about tenfold. Now, here we can see on the right-hand side the pore structure from the electron microscope, and here on the right bottom, we can see this is a lab experiment or lab study, the company who manufactures it. We have a large metallic tray. You can see this tray on wheels, a large tray with 2 old walls. This is filled with seawater. And on the right-hand side, we have a wall which has this Roman pozzolanic plaster applied on the brick as a base coat. Here we can see this dark strip. And on the right-hand side is just a normal good quality lime coat applied onto the salty brick. And everything is in seawater, absorbing seawater. And the pink or red color plaster applied on top of this base coat is intact after 22 years. So we can see a bit of salt crystallization at the boundary, but in fact it's intact, and they have been taking lab tests to see that it did not debond. That's where these drill holes are. And on the other hand, without the base coat, the plaster has completely degraded after 2 years. So just case in point. First application where these Roman waterproofing pozzolanic plasters are used, for example, walls with rising damp. Rising damp is the water's natural tendency to rise in the brickwork through capillary action, and contrary to common knowledge, is not just a problem of water, but it's a problem of water and salts. And we can see on the right-hand side some pictures at the bottom of the wall. These are all internal walls. The water rises, draws up the salts, and the crystallizing salts, which expand about 10 times in volume, the crystallizing salts break down the lime. The picture on the left, particularly, it was from an old cottage which has been painstakingly restored with a conservation officer present, and they applied a good quality lime putty plaster on these old walls. 2 years later, it looks like this. Has been completely gone. So just wanted to show you that indeed the salts, the crystallizing salts, are which break down the plaster. And then next, we have some examples from Venice of rising damp. These are all internally. We can see the breakdown of the wall fabric up to about 5 meters. Occasionally, about 3 meter is common. Fresh water produces a low rise. Seawater creates significantly higher, and that's what we have here. The full solution to rising damp obviously is to stop the rise of water by installing the damp proof course, some sort of solution, and after that the renovating part to replace the plaster, and we are going to focus on this second stage. And for example, if we take and apply this Roman salt resistant base coat, we can see the color is a dark color based on the natural materials. It stays there, bonds very well to the fabric, protects the subsequent coat. Now here, this is Venice. All these pictures have been taken in Venice, but the salt spray and the rain and everything else takes a toll of the plaster. But as you can see, the base coat stays intact. Here on the right-hand side, we have seen a house in Venice, which basically has been plastered with cement, and you can see here the whole plaster is detached by about an inch, hanging by a thread. So here we have the lime base coat versus a cement base coat. This is breathable, this is not. Here's another example. We have quite often in Venice the buildings are not plastered or rendered at the lower part because it doesn't last very long due to the high tides. And here we have the Rinzafo base coat, the salt resistant base coat, and then we have the main plastering coat on top of it and acting as a protective barrier. In the UK, this is not very much known. They are using regular lime or NHL plasters in more demanding application, but the right solution historically really is to have a salt resistant base coat because it lasts significantly longer. Next step, what we do about penetrating damp or wind driven rain. This is one of the most challenging problems in the UK. Wind at the right angle can push water through the thick walls, and as many old buildings have no cavity, they are solid walls, we have issues. And here we have in Scotland a pebble dash type of cement render on the walls, and as it ages it starts cracking, and the internal face of this wall, you can see that the moisture is coming through and also has been cemented, so moisture stays in the building fabric. And looking at the internal part of this wall on the ground floor, if you look under, we can see that the stone is decayed and backfilled basically this area here, and then moisture starts coming through at the base. The solution to this, instead of this external rendering, the cement-based render, the Roman salt-resistant base coat can be used as a waterproof, breathable render, and then on top of it you can apply normal lime mix, or inside you can apply a thermal plaster and you can make the wall insulated with a special lime mix, a thermal lime mix. Another area where these plasters, these salt-resistant base coats, they have really good application are chimney areas or chimney breast. Anyone owning an old building, you know that around the chimney area, it's always there are complications. We had a lot of cases where people called us and said, "Okay, I fixed the chimney, yet the problem is doesn't go away. I stopped, closed up the chimney, and the problem is still there." The problem is that the chimney soot contains a lot of sulfates. There are a lot of salts which attract moisture. So most often these discolorations, either around the chimney or at the base of the chimney, are because of the salts accumulated as the byproduct of combustion. And the older the building, the saltier the chimney breast area. And basically here is a very old manor house. You can see the black soot is coming through the walls everywhere, and then applying this salt-resistant base coat on top as a salt filter or salt blocker solves the problem. So this is before, this is after. This is just the base coat, and on top of it you can apply either a plaster or apply a plaster board mounted on battens, and that's the problem is finished, good for the next 50 to 100 years. And finally, waterproofing cellars. Tanking is called when you apply various membranes or cement slurries on the top of the wall to prevent the water coming through. Cement itself cracks, letting water and salts through, and also creates condensation problems. Now, a much more building friendly alternative to these type of problems, to membranes and cement, is the salt resistant Roman base coat. Here is as an example, you can apply it onto the masonry like this, and then you can apply plasterboard mounted on battens. This plaster can be applied also on the floors in the basement, so you can apply the same way on the floors, resist flooding and water pressures. If you have high water table situations, you know, when the water kind of sieves through, if you line with this plaster the walls and the floor reinforced around the edges, it resists the water pressure up to about 75 kilograms per square centimeter, as mentioned by the manufacturer. That would be it. Hope you found it interesting. If you have any questions, feel free to get in touch with us. You have the contact details below. We also have an online chat system on the webpage, so even 24/7 you can get in touch with us, leave some photos, leave some questions, and we're going to get back to you. Hope you found it interesting. Thank you very much and stay safe.